Okay, folks, our goals for today is that you could draw a position, velocity, and acceleration versus time plot from a story. We're going to take notes on drawing position, velocity, and acceleration versus time plots from a story, and then you'll get some practice doing that yourself. So recall that acceleration is here, I'm going to actually go full screen here. Recall that acceleration is the change in velocity over a given period of time. The acceleration of an object can be calculated from the following equation. So acceleration equals v final minus v initial divided by time. So a is acceleration, vf is the final velocity, vi is the initial velocity, and t is the time. So really, when we're saying v final minus v initial, if we take our final velocity minus our starting velocity, that'll be the change in velocity. So how much did the velocity change? If you divide that by the time, that will give you the acceleration of any object. So equations, we're going to be using that one, and then two that we've been using up through this point. So velocity equals acceleration times time plus v initial. And position equals 1/2 acceleration times time squared plus initial velocity times time plus initial position. And so those two should be reviewed. Only the top one should be new. Okay. So Samuel is riding his motorcycle at 30 meters per second when he spots a turtle crossing the road 50 meters ahead. He puts on the brakes and comes to a complete stop in 3.5 seconds. Use this information to create graphs on the next few pages. So just to kind of break it down a little bit, 30 meters per second, that's his initial velocity. 3.5 seconds, that's the time, that's how long he's been traveling for. The fact that he comes to a complete stop tells us that his final velocity is going to be 0 meters per second. So we're going to kind of use that on the next slide here. So on your scratch paper, you should write down our new equation. And then what we're going to do is we're going to plug in for v final, v initial, and time and solve for our acceleration to begin with. So acceleration equals our final velocity, which remember he comes to a stop, so 0 meters per second, minus his initial velocity, which is 30 meters per second, and then divided by time, which is 3.5 seconds. Okay, so this just ends up being negative 30 divided by 3.5. His acceleration is going to be negative 8.57 meters per second. On all the problems that we do today, you're going to be using this equation to start off with. And I'll just tell you, I'm going to give you 3 pieces of information from this equation, and you'll have to solve for the 4th. So for this one, we just solved for A. In all the other ones, you're either going to solve for v final, v initial, or time. And we'll see that in the next problem. Okay, but now that we know how long he's been traveling for, 3.5 seconds, and what his acceleration was, negative 8.57 meters per second, we can use that to make a graph. Start negative 8.5 is going to be about right here on the axis, and then the line is going to be 3.5 seconds long. Right? We can see if we follow it down here, it goes until about 3.5. All right, so that's probably going to be the easiest graph to make. Next up is going to be the velocity versus time graph. So that uses this other formula. Now, we really don't need the formula at this point. I think we already have enough information to make the graph, but we're just going to practice writing the formula just for practice's sake. So the formula becomes negative 8.57 meters per second squared. That's our acceleration, right? Same acceleration as over here, times t plus the initial velocity, which it's the same initial velocity, 30 meters per second. Okay, and so then we can use that to draw our graph. Really, we're just going to use the initial and final velocity, though. The initial velocity is 30 meters per second, so that's going to be at time 0. The final velocity is at 0 meters per second, and that's going to be at time 3.5 seconds. So at 0 seconds, we're going to plot 30. At 3.5 seconds, we're going to plot 0. And then we're just going to draw a straight line in between those 2 points, and that's going to be our graph. Whoops, it's just the straight line in between those 2 points. Okay, next up we're going to use our position equation. So position equals 1/2 acceleration times time squared plus initial velocity times time plus initial position. And we're going to plug in the values because we know all this information at this point. We're going to plug in those values, and then we're going to use that to generate some points to plot on the position versus time curve, and then we'll just draw a curve. So I'll show you how to do that. So half of the acceleration, so half of negative 8.57 is going to be about negative 4.28. You could round differently than this if you wanted to. If you wanted to round it to negative 4.3, or if you wanted to put it at negative 4.285, that's fine. I just rounded it like this. Plus 30 meters per second plus 0 meters. So the 30 meters per second is the initial velocity. The 0 meters is his initial position. I don't actually give you his initial position in there. I just say that the turtle's 50 meters ahead. If I don't give you the position of the person that we're talking about, you can just assume that it's at 0 meters. It'll just make it easier for your graph. Okay, and so then we're going to start off, we're just going to plug in 0 seconds to figure out where to start this graph at. Well, if we do that, 4.28 times 0 plus 30 times 0 plus 0, that's going to give us 0 meters. Well, that makes sense because that's what we wrote for the initial position. So then the first point that we're going to plot is going to be 0 seconds and 0 meters. So you can kind of write that on the side here. All right, so then next up, let's put in the final time, 3.5 seconds, to figure out where he ends up. And so we're going to take negative 4.28 times 3.5 squared. So when you calculate this, remember PEMDAS, you need to square this value before you multiply by negative 4.28. And then you'll multiply these two values together, and then you'll add it all up. I would recommend using a calculator. If you type it exactly like this into Google, it should spit out 53 meters. Okay, so that's going to be 3.5 seconds and 53 meters. That's our second point. And then to draw a quadratic graph, you need at least 3 points. Well, for my third point, I'm just going to use 1 second because I know it's going to be easy to calculate. Right, negative 4.28 times 1 second squared, well, that's just negative 4.28. 30 times 1 second, that's just 30 seconds. If you add them together, 30 plus negative 4.28, it comes out to be about 26 meters. Again, I'm rounding for both of these two values. And so our final point should be 1 second and 26 meters. Okay, and so then we're going to plot those 3 points, 0 seconds, 0 meters, 3.5 seconds, 53 meters, 1 second, and 26 meters. So 0, 0, 3.5, 53, and 1, 26. Okay, and so then what we want to do from there is just draw a nice curve through there. So I'm going to draw a curve like this. Right. So my curve ends up looking something like that. You should look similar. Okay. We're going to stop annotating. Let's go on to the next slide. So second example, Thomas is going to do an egg drop off his 45. Oh, that says feet. I didn't even realize that. Hold on, I'm going to fix that real quick. Okay, so Thomas is going to do an egg drop off of his 45-meter deck. He put a parachute on his egg to slow the fall. The egg starts from rest and then accelerates downwards at a rate of 4.2 meters per second per second. It takes the egg 4.63 seconds to drop to the ground. Use this information to create the graphs on the next few pages. So again, we're going to start off with this same formula in all of these problems. Acceleration equals final velocity minus initial velocity divided by time. We'll plug in what we know. We know that his acceleration was 4.2 meters per second downwards, so I'm going to put this in as negative 4.2. The egg started from rest, so that means it started at 0 meters per second, and it took 4.63 seconds to reach the ground. We don't know V final. That being said, though, we can already do our graph for the acceleration without knowing V final, right? All we need to know is the time and the acceleration. So the time and the acceleration tell us that it should look like this, right? Negative 4.6, excuse me, negative 4.2, and then all the way down to 4.6 for our time. Okay, but let's solve for V final. So our first step is going to be to multiply both sides by 4.63 because 4.63 is divided by, so it's on bottom. Multiply both sides by that. You should get negative 19.44 on this side. Add 0 to both sides. Our final velocity is negative 19.44 meters per second. Okay, so now we can really do our velocity graph if we want to, because we know final velocity and we know initial velocity. So initial velocity was 0, goes right here. Final velocity was negative 20, and again, remember that he was accelerating for like 4.6 seconds, so that'll be like right here. That's the line. Okay, but let's just write the equation just for practice. Velocity equals negative 4.2 meters per second squared times time minus 0 meters per second. So this is the acceleration, this is the initial velocity. Okay, and so then let's write our equation. Half of the acceleration is negative 2.1. Our initial velocity is still 0, and his deck is 45 meters off the ground, which is really high. Okay, so again, we'll start with his initial position. So we're just going to plug in 0, gets us 45 meters. So our first point is going to be 0 seconds and 45 meters. Then we're going to plug in 4.63 seconds to get his final position. That's going to be 0 meters, right? Or not his final position, but the egg's final position. So the egg's going to end up at 0 meters. This should say plus 45 here. And so that's going to be, that's not correct. Okay, catching a lot of mistakes today. So this should have said 45 meters. So we're going to do negative 2.1 times 1 plus 45. That'll get us to 42.9 meters. And so it'll be 1 second, comma, 42.9 meters. I'm not sure why it went to a second line like that. Okay, and so then for the position versus time plot, the first point that we're going to plot is 0 and 45. Second point that we're going to plot is 4.6 and 0, so like right here. And the last point is going to be 1 and sorry, I need to adjust that point because I never fixed it. Okay, so now we've got that point in the right spot. It should be a little bit above the 40 line because it was at 42.9. Okay, and so then we can draw a line through this. Again, it should be a roughly curved line. Ugh, mine looks really bad, but hopefully you get the idea. You're going to draw a curved line through those 3 points. Might not be that easy for you either, but or maybe you'll be way better at it than me. But the idea is you're just going to draw a curved line through the 3 points. Just do your best. I won't mark you down if it doesn't look good. Okay, and then there's going to be a couple